All right. Well, I'll get things kicked off. Good morning, everybody. My name is Mike Masterson. I'm one of the automation specialists with the Reynolds Company out of the Houston office. And I will be kicking off today's Tech Talk. And we are going to be talking about the PowerFlex integration with FisherROC. Our presenter today is Roger McClary, automation specialist and amateur sommelier with the Reynolds Company out of Waco. And Roger will explain later to you what a sommelier is.
I actually had to Google it.
And I want to let you know what are some of our upcoming events for our Tech Talks, which you're listening to today. They're basically 30-minute product updates. That's what we shoot for, that we're going to do twice a month. Our June topics, we're going to be looking at the Strax 5800, the new all SFP switch Rockwell has out. And then we're going to be talking on June 23rd about the integrated service agreements Rockwell have. And our users group for, I screwed up the date on that. For June, I want to say 16th will be system redundancy best practices. We will get that date corrected for anybody who wants a copy of this, but that will be on June 16th. Now, some other events that we have upcoming. We have ROC Live, which is a very popular event that Rockwell has generally done in the June-July timeframe. This year it will be virtual again, but registration has opened. The event runs June 29th through 30th, and there will be labs and a lot of talks sponsored in this event. And you can go to events.rockwellautomation.com and find the registration there. Registration is open, and you can register as early as today. Now, one other thing I don't have a slide for, but Automation Fair will be live this year. We did get confirmation from that. So look forward to probably some information on that in the September timeframe. So it will be here in Houston this year. And when we get more information, we'll let you know about it, but that will be out in November. And with that, I will hand this off to the event off to Roger McClary.
Very good. Thanks, Mike. And let's get things going here. Yeah, and I had to Google. I can't even pronounce the word, can't remember what it was. But Mike's promised me he'd come up with something really innovative to introduce me, and that sommelier or whatever is basically a wine connoisseur, somebody with a vast wine knowledge. So don't know if that name fits me, but anyway, we'll go from there. Yeah, this is going to be a tech talk on PowerFlex drives and the ROC 800, kind of a rifled approach, if you will, on this tech talk, but one we thought of importance. And just kind of want to start off with, when we say Modbus, Rockwell is probably not, or Alan Bradley is not a name that comes to mind. But Rockwell, Alan Bradley, we've always, participated in what we call the Modbus networks and such. And so hopefully we'll dispel some rumors and just kind of show you how easy it is to set that up. So this is the hardware we're going to be looking at today. We'll actually have a live demo here in a little bit. Live being hopefully it works. It's worked, like I said yesterday, 100 times already, but this will probably be that one time something doesn't work. And if it doesn't, well, it's just the way it is. We do have the FisherROC 800 is connected to my laptop, and then we have a micro 870. I will point out I actually removed the Ethernet connection between the 870 and the ROC because I didn't want it to appear that the 870 was doing any kind of control at all. We're doing everything we're showing today via Modbus RTU, and we'll explain it how we're able to do it over Modbus TCP as well if we need to in a later slide. So I will point out that the micro 870, 850, and 820 can do Modbus TCP and Ethernet IP out that Ethernet port at the same time. So we don't have to like switch back and forth. So anyway, that's the hardware setup we're looking at today. Also point out, we can do Ethernet IP and Modbus of course, and Modbus TCP using compact logics and or control logics processor. And so not to discredit or discount some of our great third-party Encompass partners, but if all you need to do is move a couple of registers across, a few registers here and there, this might be a fit. I have some several oil and gas customers who are taking advantage of this, and how you do it is with an add-on instruction. And I'll explain the add-on instruction here in just a little bit. That's just showing a picture of it. We can actually do a Modbus TCP client or a Modbus TCP server using that add-on instruction. If you, okay, this one here is the version of the add-on instruction is 2.03. If you use the previous 1.0 version, you're probably already, quit listening, or you're checking your emails, because that version really didn't, was not as efficient as it could have been. It was a memory hog. It took up a lot of bandwidth and just a lot of resources. This one has been trimmed down a whole lot. So much so that you can see there on the bottom right, we actually have 4,322 downloads of this add-on instruction since it was introduced in February of 2020. When I first grabbed it, like in March, April timeframe last year, there was just a few dozen, and so now there's quite a few downloads, and it does work. We won't be demoing this today. We certainly can. If you get with your Reynolds account manager or contact one of the specialists, we can definitely get a demo for you of it. It's pretty easy. So anyway, oh yeah, you would get that from the sample code library. It is a free download. If you just go, you can Google or whatever, search sample code, the Rockwell sample code library, and there in red it says Modbus TCP add-on. If you just search that, there's one download. You download it. It has the add-on instructions you can import. It's got a manual that's very concise and well written, and explains the add-on instruction quite well. So anyway, just real quickly, it is an add-on instruction, of course. And if we had our user, our control logics or compact logics set up as a client or a master, then we could go after our field devices, and you can have up to 5 transactions per client add-on instruction. And of course, we had 5. And one of you is going to no doubt say, well, I need 6. Okay, well, in that case, you would just import more add-on instructions. And you see at the bottom, it says you can have up to 32 client add-on instructions per communication module. And it's still pretty efficient at that point. Anyway, that's if it's a client. If you set it up as a server, then you can have up to 10 client connections per server. They don't recommend going above that. And trust me, if you need more than that, then it'd behoove yourself to go with one of our Encompass partner offerings at that point. But I just wanted to point that out, that is available. It's a free download. I actually have implemented it, and it works, and it takes up very little user memory. The first instance takes up, I can't remember the exact K of memory, but then the next instance doesn't double. It's like, it's like order of half magnitude each add-on instruction that you initiate. So Modbus, commonly used industrial protocol. I rarely ever read bullets on these PowerPoints, but these are pretty important. So just kind of a little background history. It was, developed in 1979 by Gould Modicon for their Modicon PLCs. Back when Rockwell and everybody else had their networks, we had our data highway plus, as Modicon would love to call it, data sidewalk. Always laughed about that. But anyway, it was developed at that time. Currently administered by modbus.org. Standard method for transfer of simple information, bits and integers, and it's widely accepted. Open and public domain protocol. And I'll touch on that open and public domain anyway here in a little bit. Originally developed for the serial communications, Modbus RTU that we all know and love. And then of course, Modbus TCP was implemented for Modbus over Ethernet. That last bullet, there are many non-standard extensions of the Modbus protocol. And I've run into that a few times when I say non-standard extensions, since it is open and public domain, some people have written some pretty creative drivers and such, which then if you don't have the secret decoder ring settings, it makes it hard to implement. So just kind of I mentioned that and as a side note and to be careful. And so Modbus protocol data flow, the devices communicate using client server, or you'll see it master slave technology. And the important thing to remember is a client is the master, can initiate transaction called queries and then send them to the server. The server or field device then would supply the requested data to the client, or it would take action requested in the query. And hopefully today we won't see sending an exception. In other words, why it couldn't fulfill the request. But it is bidirectional and just kind of explains a little bit of what's going on. So what are we using? I've got two Rockwell devices. One is the Micro 870. This very well could have been the 50 or the 820, either one. And I have a PowerFlex 525 drive. I'm using the free Connected Components Workbench software, or I used it to configure the two devices. There was no programming involved, albeit for one rung of logic, and I'll explain that in a little bit. But we configured all the communication ports and set these guys up as slaves so that the ROC then could be the master. And we were using ROC-Link 800 configuration software to configure the ROC-Link to control the two Rockwell devices. So what do we do? To configure the ROC, of course, we used the ROC-Link software, used our user ID and password, logged on, and then we had to configure the Ethernet devices, the Ethernet device of the ROC-Link, and so we could then go online with it. Once we go online with it, which we will hear in a little bit, this actually is a screenshot of the actual ROC-Link I used to configure it, and you can see the representation. I've got a very simple ROC setup here with a RS-485 port and no I/O, which is kind of cool because you could do this in the field, set it up just like this, and use the Micro 800 family for your I/O, and it's a lot less expensive going that route. So we have to configure the RS-485 port there in the middle. And so it's nothing magic there. Set the baud rate. I left it default. It's a little slower than you would maybe want, but very, very robust and efficient at that point. But it's 9600 baud, no parity, 8 stop bits or 8 data bits, 1 stop bit. And then you see down there the port owner. It's a Modbus master. And so that's how we configured the ROC port. And then once we configured that portion of it, you go using the ROC-Link, you still go down under the general tab, and we had to, under byte order, they're at the top left of the screen. My devices like to see data coming in as most significant byte first. There are some, I know, Siemens mag meters and such out there that like least significant byte first. So you would pick that. Even if you had devices on the same network that needed either way, even if the Rockwell device, say it's the Micro 800, you can do a byte swap type instruction and convert it that way, or set this up in the ROC-Link as well. So anyway, I just picked it that way because it worked. Master mode, start polling. Starting request is 1, number of requests 6, and we'll explain those numbers and why we picked those in just a little bit. And then request delay 1 second. You'll see actually when we start the drive, there's about a 1 second delay between the actual command and the drive starting, and that's where that latency comes in, which is typically what you want over serial maybe. And so then we go still on the ROC-Link. We're configuring our Modbus ports or channels now, and we have the you see 1 through 6. That's why we picked 6 before, because we want to actually be able to use the registers or the data there. You see the left RTU address. RTU address for number 1 node address is my Micro 870. Node address 2 is the PowerFlex 525 drive. And then, of course, there are my Modbus commands that I want to request. And then under slave registers, those are the registers that Modbus registers I'm reading to or reading from or writing to. I'll point out the 3 in the middle look like weird numbers, 81, 92, 93, and 48. Those come from within the Rockwell manual. And a lot of people don't know this, our component class drives, 4Ms, 440s, 400s, those drives, they've always been able to talk Modbus. And that's where those numbers come from. That is the 8192 is my command reference word. That's where I stop the drive. 8193 is my command speed, and 8448 is my status. That already has the Modbus one word or one offset configured in there. The reason that's important is, say you had this configured, say a PowerFlex 40 drive configured. You could unplug the 40 drive, put a 525 in there, plug the same RJ connector into the DSI port, and the Modbus network doesn't know you just changed drive and doesn't care. So the migration path would be very easy moving forward. And here's where we're configuring where we're actually putting the data. Since I don't have any mag meters or flow computers or anything else like that on our network, I have to do all this manually to manipulate the data. And so this is where I configured, how is the data coming across and where am I putting it? And that you see under conversion code 70, the number 70 and 28, that is so the data can come across in the format that each device needs it. And that information comes out of the ROC manual itself. Okay, so then we had to create some soft points because that's how I'm manipulating my data, since I don't have, like say, any flow computers or flow mag meters or anything else like that online live. And so I open up the soft point, and I'm working with all real numbers so I could keep everything in this floating column. Typically, you would want to move these over to either the long, short, or the byte, or something easier. But nonetheless, I'm actually playing with real numbers and sending across integer data. You can see right there highlighted the parameters on those registers. The first one is we're reading the ROC temperature, sending it over to the micro. Literally, that 16 is just a number. That's a tag number that I manipulate if I need to. And then the magic starts at 3, where that's the logic drive logic command word, and then the drive speed command there, and then the 3000 that actually equates to 30 hertz. So you do the math. If you want 60 hertz, 6,000. And the drive logic status word, that's the word coming back from the drive. Now you see it's a decimal number there. I could very easily bring that number into my micro 870 or something like that, and just do a any to real any to binary, and then now I've got the binary numbers, and I've got ones and zeros, and then that word 6, I'm actually reading an analog pot that's sitting on the 870. I'm reading that and sending that value over to the ROC. Okay, so how do I configure the Rockwell side of it? Here's my micro 870. This is actually a screenshot using Connected Components Workbench software. To point out, this is free software. And you can see I've got my micro 870 and my PowerFlex 525 drive. I configure both devices under the same instance of CCW, which makes things kind of nice because I can keep everything in one container using this platform. So there's my 870, and I've got a serial isolated card that I need to configure. And to do that, I just double click on it, and there we are. Modbus RTU, baud rate, parity, Modbus role, it's a slave, and the media type is RS485, 8 and 1. Nothing magic there. And then now, this is also inside the 870 using the CCW software. This is Modbus mapping. If I select and make my micro 870 a slave, there is no ladder logic that I need to move information into tags. Now, I will show you one ladder logic rung I've got and explain the reason I used it. But here, I'm just bringing in Modbus registers, and I'm moving them into tag values into the 870. There you see the ROC's temp. That test reel, that's just my number I'm bringing across, and the analog value is that potentiometer. Now, notice I don't have any speed reference word or speed command words or command words or reference words. That's because the ROC's taking care of all of that. That's why you don't see it in there. There's that one rung of logic, and that's so I can read or move the analog value of a potentiometer over to analog value, then to send it over to the ROC, and we'll show you that. So that was just one simple instruction to get that, because the ROC can't do an explicit or unsolicited message and just go get that information. I've got to place it where it needs to find it. So anyway, so what about my drive? Remember I was pointing out that the component class drives have always been able to participate Modbus. If you ever used our 1769 SM2 or other compatible device, you were playing in the manual, but you were setting up Modbus configurations. You might not have known it, but that's what you were doing. I have to tell the PowerFlex drive that your start source is coming over serial, and that's because that's where I want it to come from. And your speed reference, parameter 47, they're kind of highlighted in yellow. Speed reference 1 is serial DSI. So that tells the drive to look for its start, stop commands and its speed reference over the serial port. So how do I configure the serial port to talk Modbus? Really complicated. Parameter 123, 9600 baud. What's the node address? 2. COM loss timeout, 5 seconds. Loss actions, I got mine set to default. You can set it to like hold last state or go to 0. And then RS-485 format, RTU, Modbus RTU, 8N and 1. Those numbers should look real familiar by now. So I have all that configured and set up. So let me just kind of show you the hardware setup again. You'll see on a webcam here in just a second, hopefully. The ROC connected to the my laptop, and then my drive and micro 870. The green line between the 870 and the Modbus TCP is removed because I just wanted to be sure you understood we're doing all this over Modbus RTU. Okay, enough of me talking. Let's see it work already. So what I've got is I've got a webcam, and it is live, and it's pointed at my PowerFlex drive, my ROC, and my micro 870. If you've ever sat through any of my presentations before, I apologize for the boringness. But anyway, I always like to state my dad was born in Missouri, literally, and Missouri is the show me state. So I can make anything work in a PowerPoint. I can animate anything. So, but getting it to work live is sometimes a feat and sometimes a challenge. And so hopefully that's what we're going to do here. So you can see down here, I'm actually online with my ROC, and this is an exact representation of what it looks like. Here are my soft points I've set up. So I'm going to double click on the soft point, and looks kind of like the screen capture that we saw before in the PowerPoint presentation. That's because this is the screen capture, is where it came from. You can see there's my drive temp. There's my just a number. There's my logic command word. The last bit I sent over was a 1, which in binary is going to make the drive stop. Here is my speed reference right here. Here's my reference coming back from the drive, status reference. What is the drive doing? Remember, that's a decimal. I would have to get that into binary, but nonetheless, that's no problem. And this is a real number coming from the pot. Okay, so if you can see my drive, yep, I think you can see it. And this is where we do a little finger crossing and praying, and I click apply, and lo and behold, the drive starts. And that command, like I said, I'm sending that through the ROC over to my drive. You can see the serial cable going up into the drive. That's the DSI connection going up into the PowerFlex drive. Daisy chains over to the ROC. Daisy chains over to the 870 into that that card right there. There's kind of, maybe you can't see it, but there's my serial cable going into the 870. If I want to change the speed of the drive, make it go 30 hertz, I just change it to 3000 and click apply. And our drive takes off and run. If I set it to auto scan, now I'm actually polling these tags, and you might see the temperature of the ROC change back and forth. That's actually the internal temperature of it. And then the value 6 is actually that analog pot. And if I reach across here and crank it up a little bit, you see those values changing. So, and if I want to stop the drive using soft points, I've got to stop scan, and then I can change that back to a 1 and apply. And lo and behold, our drive stops. So that's just showing that we can control and move data back and forth between Rockwell Allen Bradley devices. using Modbus RTU and the ROC can be the master. So that's pretty well what I wanted to show you. I think I'm about 4 minutes early as well. So Wayne, Brian, anybody want to have any closing comments or anything? Or if we had any questions come in the chat, maybe I can try to answer them.
We do have a question from John. Does the ROC-Link 800 interface with other Modbus TCP connections, such as the PowerFlex 753, over the COM module with the COM carrier on the 753?
Yes, they're very good point, and I'll delineate the difference, if you will. The component classes, unless you have that comms card in there, they cannot do Modbus TCP. They can do RTU. The architecture class, the 753, 755, can do Modbus TCP. We just need that card in there. I have not configured it, the ROC-Link using the Modbus TCP port. But since I have talked to the my Micro 870 as well as a Compact Logix using that add-on instruction, I feel very confident and no reason why the 753 using the Modbus TCP card would not work. I have not configured that myself. I have some customers that have done it. They haven't returned the drives nor the card, so I'm going to make the assumption they got it working. Hopefully that answers the question.
All right. Thanks, Roger. I don't see any other questions or comments from the audience. So thanks for the presentation. It worked really well.
And like I say, if you want any further deep dives on that AOI or anything you've seen here, we just had a 30-minute window. So that kind of precluded a lot of stuff. But if you need deeper dives, get with your specialist and or your rentals account manager, and we can definitely set up a deeper dive into anything you've seen here. That's it.
Thanks, guys. Everybody have a good day.
Thank you.